going to start with the first topic of logical reasoning, which is series completion. Okay. Now, guys, in this particular topic, we are going to focus on number series, alphabet series, and alphanumeric series, which will be the combination of alphabet and number series. Okay. So, as I've told you, in this particular topic, you'll have 2 or 3 types of questions. Okay, so we'll have a small introduction. So both we'll talk about PPTs later on. Like, is my screen visible, guys? If my screen is visible, then I will continue. Yes, okay. Thank you for your responses. So, in this type of questions, we have some numbers and or alphabet letters are given. They all form a series and the series changes in certain order. And finding out the order is what you need to do in this topic, okay? The series may have 1 or more numbers or letters missing, and the students are required to observe that specific order in which the series changes and accordingly complete the series, okay? So basically you get 2 types of question. One is where a particular series is already given to us and we need to identify the pattern and find out the next term, okay? Or a particular series is already given to us and one of the terms in between is missing. So we need to find the pattern and we need to fill the missing term, okay? And in some of the cases, if you are planning for, let's say, SSC exams and all, so out there, they actually give a series where one of the terms is wrong. So you need to find out the wrong term missing, wrong term, okay? That is a little bit more difficult. So first of all, we'll start with the basics. So tricks to solve these type of series completion questions. So the first step involves observe, are there any familiar numbers in the given series? Like, first of all, we are talking about number series, okay? So this is the tricks which I'm going to discuss right now will be related to number series. So observe if there are any familiar numbers in the given series, like prime numbers. You are very much familiar with prime number, right? If I write 2, 3, 5, or if you get to see 2, 3, 5, 7 somewhere, then you realize that they are prime numbers, right? Similarly, perfect squares, you very well identify perfect squares very quickly. Cubes. Now, guys, for this particular topic, you need to remember the squares from 1 to 25 or from 1 to 20 at least, okay? From 1 to at least you need to know all the squares from 1 to 20, and if you can remember it from 1 to 30, then it will be very good. Similarly, when it comes to cubes, so you need to remember all the cubes from 1 to 15. Everyone remembers a cube from 1 to 10. You also need to remember the cubes from 11 to 15, okay? Especially the cube of 11, 12, and 13, which is very important. Now, whenever you get a question based on number series, what you can do is, in step 2, we say that calculate the differences between the numbers, okay? Let's say if I give you some particular series, you can calculate the difference between the consecutive numbers, okay? And observe the pattern in the differences. The reason why we do is it because in 90% cases, the pattern is there in the difference. So if you are able to find out a pattern in the differences, then you can very well solve the question, okay? Now, what can be the possibilities? Think, if I give you a particular series, let's say 1, 3, 10, 32, 65, 97. Likewise, I'm giving you a particular series. And now you're finding out the differences between the first and the second term, then the difference between second term and third term. Likewise, you're finding out the differences, okay? Now, there can be certain scenarios, like the differences might be growing rapidly, right? So if the differences are growing rapidly, then you need to realize that it will be a square series it will be a cube series or it will be a multiplicative series, because as you increase the number, the value of the square of that number also increases, right? For example, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So now when you're going to the next natural number, the square is farther from the previous one, right? At a farther distance. So whenever you see that the differences are growing rapidly, then most probably it will be either based on square, cubes, or it will be certain multiplication. Okay. And similarly, if the numbers are growing slowly, if the numbers are, let's say, increasing slowly, then it will be a scenario of simple addition series where a constant number is being added. Or if the numbers are decreasing slowly, then it will be a scenario of subtraction. Okay. But if the numbers are decreasing rapidly, if the numbers are decreasing rapidly, then definitely it will be a scenario of division. Okay. And so this is generally what you need to do. Now, step 1 and step 2 is what you are going to follow when you have 5, or let's say at the max 6 numbers in a given question. 6, like the series consists of 5 or 6 terms. But in some cases, if you have seen, they give you series which contains 8, 10, 12, 14 letters also. Okay. It contains 12, 14 elements in it. So in that case, it might be a double or triple series where the letters at the odd position will form, let's say, some particular series, and the letters at the even position will form some other series. Okay. So when you see that the number of terms is 8, 10, 12, 13, likewise, okay, more than it. So you need to identify that it will be a scenario of double or triple series. Okay. And secondly, it might be a sum or average series. Okay. Now what happens here is, like we'll do some questions. Okay. Good evening, Chandan. Okay, so step 2 says it might be a sum or average series where the sum of first 2 terms will give you the third term and so on. And sometimes numbers will be multiplied and will be added to another number. So we'll check all those patterns. Okay. So we will look into some of the series. Prime number series. Now you know what are prime numbers, right? 2, 3, 5, 7, 11, 13. So you can very well identify that the given series is a prime number series and the next prime number will be 17. Now look at example number 2. Example number 2 says 2, 5, 11, 17, 23. Now you can see that in example number 2, the numbers are prime numbers, but they are not consecutive prime numbers. So now in this scenario, you will have to identify that after writing 2, they directly went for 5. So they have skipped a 3 in between. Similarly, from 5 to 11, they have skipped a 7 in between. So now they are actually writing down the prime numbers in an alternative way, right? Similarly, we can see we have a different series, 2, 5, 8, 11, 14. You can see that the numbers are growing by a constant, right? And the constant is 3. Similarly, in example number 2, the numbers are decreasing slowly and they're decreasing by a small number. Then we have a multiplication series. The reason why I want you guys to check out all these series is so that you can know how to approach the question. Like in the first one, you could very well identify that they were prime numbers. In different series, you can see that the numbers are either increasing slowly or the numbers are decreasing slowly. Okay. So if it is increasing slowly or decreasing slowly, then it will be simple addition or subtraction. Now, multiplication series. If you remember in the introduction, I told you that in multiplication series, the numbers, they grow rapidly. Okay. So in this multiplication series, we have 2, 6, 18, 54, 162, and so on till 1458. Okay. So now you can see that as we are going to the next term, the gap between the number is getting increased rapidly, right? And in this type of scenario, please try to identify that if it is a multiplication series, square series, or cube series. Like in this case, it was very easy for you. From 2, we got 6. So we could have said that it is 2 into 3. And if you follow the same, 6 into 3 gives you 18. 18 into 3 gives you 54. So whatever pattern you identified in the first two terms, you also need to verify it in the next pair of terms. Okay, so 2 into 3 gave you 6, 6 into 3 gave you 18, 18 into 3 gave you 54. So the pattern is what, nothing but the numbers are multiplied by 3. Okay, similarly in the example 2, you can see that the numbers are increasing again rapidly, and now it is a multiplication of 4. Okay, basically the numbers are multiplied by 4. Then you can see point number 4, division series. When you divide something, the value decreases, right? So similarly in the division series, you will see that the numbers are decreasing. Okay, and the numbers are decreasing rapidly. So from 720 you got 120, from 120 you got 24, and this is going on till 1. So it started from 720, it is ending at 1 in hardly 7 to 8 terms. Then you need to identify that this will be a scenario of division series. Can also be factorial. So I will also look into factorial series. Okay, like this particular example number 1, you can say it is also a scenario of factorials. But look at example number 2. Example number 2, from 32 you got 48, from 48 you got 72, from 72 you got 108. So you can see that the numbers are increasing rapidly, but it is not a simple multiple. Okay, you can see that it is increasing by 1.5. Like from 32 you got 48. So from 32 you got 48. If you find the difference, you see that the difference is 16, and that 16 is actually half of 32. Then from 48 you got 72, from 48 you got 72, which is 24. Now that 24 is actually half of 48. From 72 you got 108, which is the difference is 36, which is half of 72. Okay, so you can see that I also found a pattern just by calculating the differences between the terms. Okay, similarly you can see that we can also have square series. Now try to identify that it's not possible that you'll always get a simple square series. Like 0.5 says n squared series, 1, 4, 9, 16, 25. This is a straightforward square series. But look at point number 6, which is n square minus 1. Okay, now what is n square minus 1? The point number 5 example 1 is the same as the example of point number 6. The only thing is the consecutive terms have been subtracted by 1. Okay, so now if I say 1, 4, 9, 16, 25, what are these? You will very well identify that these are nothing but perfect squares. But when I give you 0, 3, 8, 15, 24, and I ask you what are these, now you might get confused because they don't fall into the category of prime numbers. They don't fall into the category of squares or cubes. So now you will have to figure out that even though 0, 3, 8, 15, 24 and all, even though they are not perfect squares, but they are very close to some perfect squares. Like 0 is close to 1, 3 is close to 4, 8 is close to 9, 15 is close to 16, closer to 16. So we can see that the given series is just the number previous to a perfect square. So this is how you will identify that a given series is closer to perfect square or not. Okay, similarly point number 7 includes n square plus 1. So n square is there, n square minus 1 series is possible, n square plus 1 series is possible. Similarly, it can be n square plus n, it can be n cube, it can be n cube plus 1. Now n cube is nothing but the perfect cubes. But 2, 9, 28, 65, 126, these are not perfect cube. These are the numbers just next to a perfect cube. So you will have to practice, and you will always have to look out for some patterns in these type of questions. Okay, if you are like in most of the cases, the finding out the difference between the terms will help you. But if you are unable to find out any pattern, just try to look for squares, prime numbers, cubes, because in 90% of the basic tests, The number series are simply based on multiplication, squares, cubes, and um, or addition subtraction. Okay. And lastly, we have factorial series. And just before factorial series, we have an xy comma x plus y series. This is very important. I've seen this coming a lot. Now you can see that there are 48, 12, 76, 13, 54, 9, 32. So you can see that the numbers are increasing, decreasing, increasing, decreasing in an alternate way. Okay. So now you will not, and none of the given numbers are like, they are not coming into the series of prime numbers or multiplication or division or perfect square or perfect cube. Okay. So when you are unable to find out any such pattern, but you see that the numbers are increasing, decreasing alternatively. So just check out if it is xy into x plus y, xy comma x plus y. Okay. And then we have lastly the factorial series, where you get like we have already discussed factorials in permutations, right? So you can simply get a question based on that series. So these are the simple basic things which you need to remember, whenever you will get a question on series. Naveen is asking, how can we identify those questions for XY? Naveen, that will come with practice. Okay. It's not possible that straightforward you'll be able to identify that it's a pattern of XY, but yeah, after going for some practice, you will be able to figure out. Okay. Like what is the unique thing about XY comma X plus Y? That numbers are increasing, decreasing in a consecutive way. And you can see that 48, 4 plus 8, 12. Now from this 12, there is no relation of getting 76. 76 came unique, right? It has no relation with the first two terms. Now 7 plus 6 gave you 13, right? Now you're not getting 54 from this 13. So these are such things which you will learn with practice. Series is a topic, guys, which needs a lot of practice. Okay.